Well, I'm back, guys. Here we go. Gonna wing another one. Got you on the coloradostate.edu, and the link, it'll be the top link in the description box, showing you the Himawari satellite view of the Earth, full disk. Click on natural color. That gives you the best shot of this object that they're trying to hide. So same deal as well, the 17th is when they first identified this thing, I believe it was. And there you have it, 1340 UTC, or that would make it about 1040 Melbourne, Australia time. You can see they got this whole thing pixelated out on this Himawari. You can see that some of the light shining through there. We got more. Rolls through pretty quick. So that would tell me it's still pretty close to the satellite. And it's a weather satellite. Himawari, it's in the geosynchronous orbit, 22,241 miles above the Earth, I'm told. It's either 22,236 or 241. It's somewhere in that geosynchronous orbit range. Still got the beams of light reflecting, white, sun's yellow, so the sun simulator is white. That has to be from the sun simulator, plus the scope of it, it's just too focused. The sun simulator being small, like it is, but very bright when it's reflecting off something, apparently, at least from these cameras. It's picking up some beam action. I'll let it play through so you see what it looks like. What you do though is make sure you put it on 60, put it on the lowest number of minutes. That'll make it play the slowest, and then I always pull it back here to the slowest speed. So here we go, it'll play through. It's just a natural shot of the Earth. And I don't know why it stops there. Oh, I know, it just rolls back over. Well, there's 19. Okay, then it goes to 10. Why does this thing stall there? That doesn't make sense. Why is it stalling there? It doesn't stall when I drag it. So there's the 1830. So you add 11 hours to the UTC to get the Australia time. But basically, it's coming around exactly 12 hours apart from the other one when it shows up on GOES, because that's showing up at 4 UTC. Once you subtract 5 hours, that would make it 11 Eastern Daylight Time. So it's exactly between Australia on this side when it comes around, and when it comes around on the other side, it's exactly 12 hours back at 11 p. Well, yeah, 24 hours really. I mean, if you look at the hours. It'll be 11 p.m. showing up in the Eastern Daylight Time area of the globe, which I showed you on the goes this morning. And same deal in Australia, 11 p.m. East, 11 p.m. Australia time, Melbourne time anyway, which Melbourne's down around in here somewhere. So here we go, 11 p.m. Sun's coming up. Why would it be coming up already? It's coming up on the other side of the globe. So 17 UTC plus 11. 7 would make, that's 4 a.m. I guess it's coming up around this way. So add 11 to that. Say 18, so that's 424 plus 7, so that's 630. Yeah, so that makes about sense. Anyway, got a little caught up there. But check this out, man. This is the space weather, the latest run, last 300 frames. These three are synced, 1, 2, 3. These two are synced. One thing you notice right away, we're getting a whole lot more electrons bleeding in from the backside. You can see them spilling in. And these two aren't exactly synced with these three. Can't really get them to sync up and play through together. But it happens around 9, it starts around 9:36 on 21. So watch coming around. Start spilling in a little bit. You'll see some red spill in. There it is, 9:36. Really spills in now. And by 12:30, it's full blown spilling in. That's UTC, so take 5 off of that. That's 7 something, 12, 7:30 Eastern Standard Time this morning. I'll watch the wind speed. It gets up around 6 a couple times. And this is all being recorded by these GOES satellites rather in here. And that's the same with the Himawari, where I showed you the this thing coming through. That's out here in this geosynchronous orbit. So whatever it is we're seeing on the RAM B is right close to 22,200 and some odd miles above the Earth. And so far, the way it's been playing through, it hasn't changed much time-wise. So I'm thinking still maintaining a similar altitude as when we first discovered it. At least it's been showing up at the same times, and the beam action hasn't really looked that much different. But you can see they have the whole thing pixelated out over here too, and on the bottom. Anyway, we'll go back here and look. This is getting pretty bad. Like I said, maybe the calm before the storm when I made those other videos and showed you the pressure equilibrium. Lasted from about midday on the 16th up until just yesterday. We started seeing some color again on those geospace pressure models. And I'll show you that in a minute. I still got some color on those. But these electron bleeding in, that's pretty significant. There's really not much missing time in here. Maybe 20 seconds here and there, but pretty much it's a cleaned runs. So watch these arrows. This will show you where the solar wind pressure is coming from. You can see mostly they're in the right positions now, coming from the sun side and heading right to left. But when you get these electrons starting to bleed in, see how the arrows are starting to push back, and then here we got all that backside pressure showing up there. All those blue interplanetary magnetic field lines, which we should only have about 9 of, because we have one sun and 9 planets to make interplanetary magnetic field connections to. But as you can see, with Nemesis being in the neighborhood and reportedly having 7 planets, look at that. That's bad. There's way more than 9 of these blue interplanetary magnetic field lines. And another thing that I don't think I ever pointed out, look how many of them are bunched around the Earth. So that's another indication that Nemesis is pretty close by the planet. So I'll show you the geospace. Well, that's the velocity. Never really get much from that. But you can see some of the, since the solar wind speed came up, it's getting buffeted a little bit from solar wind, but the solar wind's not that high. I mean, it only went up to, started climbing midday today, UTC, early this morning, Eastern Standard Time, and then it went up to 383, and then it's starting to come back down. So that's what you see buffeting the magneto on the velocity thing. Here's the solar wind density, like I showed you this morning, and I'll put the links again in the description box. The average solar wind density is 4 to 6 atoms per cubic centimeter, and the highest recorded, at least that I found anyway, was between maybe went up to 15.9, but that was after a CME. And you can see the solar wind density was piling up, went up as high as 34. There's a 35.73 in there. Well, that's coming back down now. But it's still well above average, 2 to 3 times above average. So here's the geospace again. These things get stuck. Okay, here's the density. One thing I did notice, now this is the like Z-cut that we see on when I showed you with the arrows. Of course, they have them reversed. They don't ever make anything real easy. Got the sun side on the left, but here you see the density. So there's still quite a bit of density around the in the space, which I showed you on, Discover. And I'm running out of time here, but so I'm not going to be able to make this one last point I was going to make. It's not that important. But here's the pressure. See, it's red now. And this is the Z-cut. It's looking straight down on the planet. And this is the equatorial plane, the Y-cut looking straight across. They take a slice out like an MRI, cut plane, and then they turn it on its side and you can see it. So that's just another way of looking at what's going on. Still got the magnetic resonant grid pattern around the sun on certain angstroms. We still got the magnetic resonant grid pattern in the clouds on the Earth, and this has been going on from at least since April. Clearly, we're in the grips of Nemesis, and we're in struggle, caught in between Nemesis and the sun, as you can see by the Solar wind density readings. Oh, wow, I'm running out of time already. I can't believe it. God bless, peace, and I'm out.